Hello everyone and welcome to the video about zero-shot learning using Python. Zero-shot learning is a concept that is typically related to NLP, natural language processing. And in this video, we will see what exactly it is and how to do it using Python. So what is zero-shot in the context of text classification? Well, its main goal is to classify the text documents that you give it without using or seeing any label data beforehand. So basically, this model doesn't undergo any training whatsoever. Transformers or deep learning architecture are basically the models that are responsible for like 99% of the zero-shot classifications. Hugging Face is a community, a web-based community of engineers, deep learning engineers, where you will find many transformer-based models and datasets. So you can download those datasets and try whatever we discuss in this video on those datasets and report your results in the comment section below. Now in this video, we will proceed to zero-shot text classification. We will use two different approaches. One, transformers from the Hugging Face hub, and second, the tar classifier from the Flair package in Python. First, like I just said, we will implement zero-shot learning using transformers. On Hugging Face, you have more than 60 transformers available, and for obvious reasons, it is not possible to implement each and every one and show each and every one. Thus, what we are going to do is I will show you the implementations of the three most popular transformers available on Hugging. So before we try this approach, there is a prerequisite, and that is a transformers package. If you haven't installed that, I would recommend you do so using the pip install command. If you're using Jupyter Notebook or any notebook like AWS SageMaker or whatever, you will have to prepend an exclamation mark before the pip install command. So now once you have installed transformers package, we are ready to use transformers for zero-shot learning. So let's see the first approach. The first model that I would like to show you is the bart-large-mnli model developed by the Facebook researchers. This model is available on Hugging Face. You can download it using code, not manually. You can download it in your script and then use it for zero-shot learning. So now I will show you the code. So as you can see, I installed the transformers package using the exclamation mark pip install transformers. Then from the transformers, I imported the pipeline submodule because I will be using it to build the pipelines. Next, I built my first classify pipeline using the model Facebook/bart-large-mnli. Now to test this approach, I tested in a variety of scenarios. The first sequence that I'm testing it on is a simple phrase, I love traveling. Now this phrase can belong to 5 different labels that I have listed down below in the label candidates variable: travel, cooking, entertainment, dancing, technology. Then I use this pipeline, this classify pipeline, to predict which label this sequence belongs to. And here we see in the output, we get a Python dictionary. Now this dictionary has 3 keys: labels, scores, and sequence. Labels is the set of labels that you would like the model to choose from. Scores is the score, this is the probability of which label the model thinks the sequence belongs to. The scores list is arranged in a decreasing order. The label with the highest probability is given first, travel in this case, which makes sense because the sequence I love traveling belongs to the category of travel. And then thirdly, sequence is the sentence or phrase that you're testing it on. I love traveling in this case. Okay, so I tested it on another input sequence. This one I got from Wikipedia. It's a phrase, it's a line about quantum machine learning, which has absolutely nothing to do with traveling, our previous example. Again, we use the same 5 label candidates, and here we see technology. This is the label the model thinks is most appropriate for this input sequence, which again makes sense because quantum machine learning is technology. Now next, I have implemented multi-class classification. In these first 2 examples, as you can see, all of the probabilities they sum to 1, and this is because only one label was being predicted. In this case, as you can see, 96% plus 3%, so on. Here in this case, 92% plus 2.3% plus 2.1%, so on. All of these 5 and these 5, they sum to 1. But what if your input sequence can belong to more than one label, or more than one label is apt for your input sequence? Here in this case, this is a line about dance, which is a form of entertainment. So dance and entertainment are actually two labels that are related. And when I run this with the multi-label equal to true flag, you see that I get a 97% probability for the label dancing and 87% probability for the label entertainment, which means that this model thinks that these two labels, dancing and entertainment, are apt for this sequence, which is true. The model is not wrong. Now I will show you another model. Now this model is not a transform. This is a transformer, sorry, but this is a cross-encoder model, cross-encoder based model, which was trained using the SNLI and the MNLI datasets. This model can obviously be used for both cross-encoding as well as zero-shot text classification. So this model sounds interesting, right? I will show you the code. So as you can see, I'm building a classifier here with the model Cross-encoder / nli-distilroberta-base. This downloads the model before using, obviously. And then the sequence I want to predict the label for is I can perform article. Now this is very poor grammar, but this example, it shows you that the classification doesn't depend on the sequence's grammar. So I have three labels here: writing, management, and checking. Now I can perform article. Article is a piece of writing, and you would expect writing to be the label that the model thinks is the most appropriate, and that is indeed the case. Writing is the label that comes up with 68.9% accuracy. This is obviously not 90%, but this is still clear majority, clear winner among these three labels. Next, I show you the bart-large-mnli model built by Navteca. So this model, like its name suggests, is based on the bart-large model and trained using the MNLI dataset. An interesting fact about this model was that it was specially designed for zero-shot text classification, which is what we are going to use it for. Sounds interesting, am I right? I will show you the code now. So it's a little long, this code. So here, as you can see, I'm importing the required submodules from the transformers package. Once I've imported that, I create the model, and this model is this bart-large-mnli model. And then I'm creating a tokenizer to tokenize the input sequence. And then I finally create a pipeline in which I give the model as the bart-large-mnli model, and the tokenizer as a tokenizer that I just instantiated. And then finally, I'm testing this zero-shot text classification on the sequence that I had earlier. I am writing, I can perform article, and with the three labels: writing, checking, and management. And again, you see, this model predicts the label writing with almost 81% accuracy for the sequence I can perform article. So this is better than the previous model, the cross-encoding based. Okay, so now until now we have been talking about implementing using the Hugging Face hub, the models available on Hugging Face. But there is another option, and that option is the Flair library for Python. Why this works is because the Flair library has a TARS classifier model, which is specifically designed to perform zero-shot text classification. If you haven't already, you can install Flair using pip install Flair, or if you're using a notebook environment, then !pip install Flair. Now once you have installed, you are ready to perform zero-shot text classification with this package. Let's go. So here I just downloaded the package, installed the package, then I have imported the TARS classifier submodule from the Flair package and created an instance of that. This model is based on the TARS base model. There is another model of TARS available which you can also use, but I felt that TARS base was good enough for this sequence because it is obviously not very complex. Then in the next cell, I create an input sequence, and this input sequence, in order to work with Flair library, has to be a sentence, and the sentence is, "I am so glad to use Flair," which is quite right, quite true. The two classes I think that this sentence can belong to is either happy or sad, and I want to see which one it belongs to. I finally predict it using the newly created classifier, and I see that the sentence "I am so glad to use Flair" belongs to the class happy with a probability of 89%, which is quite nice and correct, obviously. So finally, that's all for this video. In this video, we discuss zero-shot text classification, and along with zero-shot text classification, we also discuss the Hugging Face Hub and what all you can do from that. We went through the Flair package, we went through the TARS classifier from the Flair package and how you can use that for zero-shot text classification. We saw that all of these approaches had pretty good performance and always predicted the correct labels with very high probabilities. Now, once you have mastered zero-shot text classification, the next logical step is few-shot text classification. Now, few-shot learning is learning based on only a few labeled examples, usually in the single digits, not even double digits. Alright, thank you for watching this video. I hope you learned something. I look forward to seeing you in the next lecture. Bye.